Hi, I'm Shane, and today we're going to be talking about different ways to utilize ArtemiS SUITE's ASX features to create tools that can help you optimize your workflow and create new possibilities that you didn't have before. ASX is a set of programming tools that help you control different aspects of ArtemiS SUITE. Now, in practice, ASX is a code-based tool. It uses a bunch of APIs to control different parts of ArtemiS SUITE. But for the sake of this presentation, we won't actually be going into any of the nitty-gritty code stuff. The important thing to note is that ASX works through .NET libraries, which means that getting started with code is as easy as using just a few import lines. ASX will work with any language that can use .NET libraries, like C#, MATLAB, and Python. I'm a MATLAB guy personally, so I'll be working with that today. But the documentation included with ASX has lots of example code for other languages too, so you can always work inside the environment you're most comfortable with. For this presentation, we'll talk about a few different scopes to use ASX in order to give you a little inspiration, or maybe even help you just visualize a few things that you didn't know were possible. If you do end up with any questions about the process of writing code, or alternatively, if you see something here that you like and you want to adapt it into your own workflow, feel free to reach out to info@HEADacoustics.com for some more information. First, let's go over some quick background as to what ASX actually is. ASX is a set of currently 7 licenses that controls individually 7 different parts of ArtemiS SUITE. ASX 00 lets you batch process files from the command line. It also includes the documentation, and as a bonus, it's free. ASX 01 lets you read and write HDF files, both time data and analysis data, with code. ASX 02 lets you control the ArtemiS SUITE interface and use its calculation functions without interacting with the interface itself. ASX 03 lets you add custom functionality to Scala. ASX 04 lets you control Suite Recorder and different aspects of data acquisition. ASX 05 lets you automate user documentation and file metadata. And ASX 06 lets you add code within the analysis flow of ArtemiS SUITE itself. We won't touch on all of those today, but we will discuss 3 practical applications that combine a couple of the different ASX APIs. First, let's work inside ArtemiS SUITE to add a little functionality within an interface that we're already familiar with. You may know that Suite already has the ability to add a 2D tolerance curve to an analysis. But what if something comes up, like a complicated customer spec, where you need to meet a 3D tolerance curve? Perhaps something like an FFT versus RPM analysis that has to conform to this kind of shape. Without ASX, your workflow might look something like this. You manually export 3D analysis data from Suite to a CSV file, import it into Excel, and then subtract each point of the tolerance curve from the analysis data and look to see what comes of it. Extra wrinkles get tossed in if you need to come up with a nice visualization to show someone later, or if the dimensions of the tolerance surface don't match up exactly with the data from Suite, or if you have to do that whole thing a bunch of times in a row. Something like this can end up being a pretty big pain in the butt. But if we use a little ASX magic through MATLAB, we can make that whole process as easy as any other analysis within ArtemiS SUITE. We'll use a combination of ASX 01 to read and write HDF files, and ASX 06 to add our code as its own analysis within ArtemiS SUITE. We'll skip over the code details here, but imagine that we wrote something in MATLAB that lets us take in FFT versus RPM information and then subtract it from a surface of data points. We can add that code to a pool project using a post-analysis add-in, which is a part of ASX 06. We can have Suite calculate an FFT versus RPM, and then we can hand off that data to MATLAB, which will handle all of the tolerance surface stuff. Then, MATLAB gives that data back to Suite, and we can visualize the results just like any other analysis. It works quickly, and since there's no manual processing that you can accidentally mess up, it's totally accurate every time. In practice, that might look like this. We have a test file in our source pool, and in our analysis pool, we have both an FFT versus RPM and a post-analysis add-in, which sends this FFT versus RPM, or one just like it, to our MATLAB function, and then from our MATLAB function back to ArtemiS SUITE. We can calculate just a plain old FFT versus RPM. And then we can go back and separately calculate our post-analysis add-in. If we tile the two, We can see over here that we have our original FFT versus RPM, and over here we have that FFT versus RPM subtracted from the surface that I showed earlier. Now it might be a little difficult to tell because the scales are slightly off, but if we adjust those, now we can see all of the frequency content that is above our tolerance surface. So that's one way to use ASX within ArtemiS Suite itself. Next, let's look at visualizing data outside of Suite. Let's say we want to learn more about the directionality of a source. We'll rotate it at different angles and use an array of microphones to listen in on frequency content. This winds up being a pretty specific use case, so there's no easy tool within Suite to help us do this. But we can use ASX01 to custom build a utility that makes looking at this data easy. So if we have an array of mics here and a source here, we could take a recording of the source playing a sound at a bunch of different angles. The response of the mics at each angle will tell us the directionality of the source. But how do we package all of that info into something that we can communicate with someone else? In this example, we pre-process all of the recordings at all of the different angles in Suite first. Then we have a MATLAB utility read in those files using ASX01. From there, MATLAB picks out a level value at a specified frequency point across all of the recorded angles, across all of the recorded mics, and plots them in a single surface. This axis winds up being the mic, this axis is the angle, and the height here represents the frequency response at the frequency value specified by this slider. We can move this slider, and now anybody can see how the surface changes alongside frequency. This ends up being a long-winded, mildly complicated example, and in some ways that's the point. Without the ability to visualize complex ideas, communicating analysis wants and needs can get muddy quickly. But using ASX and MATLAB together, we can bridge the gap and make sure that everybody always knows what's going on. Last, we'll check out a more full way to create tools that make complicated analysis work easy enough for anyone to do. The best example of this is probably an end-of-line test setup, using an interface built in MATLAB that controls data acquisition, analysis, and results presentation all at the click of a single button. Most of the time, the repetitive task of acoustic EOL testing needs to be handled by an operator who isn't necessarily versed in acoustic analysis. This, coupled with the fact that there are more than a few steps involved in this process, makes things a little tricky if you don't already have a good relationship with an integrator. To successfully run an end-of-line test, a part needs to be placed in a test fixture. Then it has to be excited and recorded. That recording is then sent through one or more analyses, and the results of those analyses are then compared against set pass-fail tolerances. Without ASX, performing all of these actions requires lots of time, familiarity with the software, or a reliable integrator, or maybe even all of those together. Using ASX to package everything under one button allows any operator to successfully run a line while also keeping a compact log of important data so engineers can analyze line trends or identify issues at any time. In this example, when the Analyze button is pressed, we'll use ASX04 to tell Suite Recorder to create a 5-second recording. That recording has a name that's already date and time stamped to prevent confusion in the future. Once that's finished, ASX02 takes that recording and runs it through a gauntlet of analyses, in this case, loudness, sharpness, and tonality. Then, MATLAB compares those values against a pass-fail surface that was developed beforehand by the HEADacoustics consult team. After the recording is verified, a light on the interface turns green or red to indicate the test results in a very clear manner. We can also present more complex information if we'd like the 3D score of the recording versus the tolerance surface that I mentioned before. This doesn't have to appear on the interface, but I included it because it looks flashy, and that's what it's all about. As one last added bonus, using MATLAB, I can compile this software into a standalone executable, and that means that this software can run on any computer regardless of whether or not it has MATLAB. The computer that runs this software still needs to have ArtemiS Suite and the appropriate licensing, but if you only have a few MATLAB licenses to go around, ASX can still work for you. Here, ASX took a problem that was either expensive or time-consuming and boiled it down to a single button press. So that about wraps up the presentation surrounding possibilities with ASX. There's an infinite number of other possibilities to cover, but hopefully this gives you some ideas on how you can expand your capabilities with these tools. If you have any questions, talk to your sales rep or email info@headacoustics.com. We can help you figure out the tools that you need to get the job done, and our consulting team can work alongside you to develop solutions that you don't have time for right now. We look forward to hearing from you soon.